So now most of the tests, they are standardized. Few tests we do during your mix design process or when you are standardizing the mix, and few tests we can do on the regular control over your production, like flow test is there or density is there, that one has to be. So vocabulary and consistency, we will discuss this separately. What are the tests, which is the IS code, what is the procedure, one has to understand. Bleeding and settlement, that is also test. Setting time of concrete is also a test which can be done in the laboratory to understand the importance of setting time. Now this setting time is totally different than setting time of cement. I'm not talking about setting time of cement, I'm talking about setting time of cement, concrete. Now there is a code for it. Now we'll discuss about this also. Then air content, because when you are working for cold weather conditions, suppose in Himalayas, Leh, Ladakh, where the temperature goes sub-zero, where in the concrete itself you have to add some air into that, additional. So that one has to understand how to come out with that, and air content one has to entrained in the concrete as per the requirement for the ambient condition. Then temperature. Temperature as concrete is also very, very important in this, because right now in Mumbai you see a lot of high-rise buildings are coming up. The height of the building more than 150, 180, 200 meters. The depth of raft is 2 meter to 2.5 to 3 meters, sometimes 4 meter. So at a time, the raft concrete is in the tune of about 2000 to 4000 cubic meter. Now you can imagine so much concrete if you produce in the normal temperature, what will be the core temperature of that particular raft. And as per the code, now the new code has introduced in 2018, I think. Yeah. The core temperature of concrete should not exceed 70 degrees centigrade. That is the requirement. So one has to work with your proper cementitious system where my temperature should not go more than 70 degree at core of the raft, and my temperature gradient, mean core to the surface temperature of the concrete, should not be more than 20 degree. This is the requirement. If this exceeds, there is a possibility that you may get thermal cracks in the foundation. So here the concrete mix design plays major role for selecting the proper cementitious system to reduce the temperature at core. That is one. Secondly, your placing temperature has to be low, not with the normal temperature like 32, 33 degrees. No, it's not acceptable. Should not be more than about 28 degree. Still it is below is always better. Now how to come out of that? There is a standard procedures and standard practice people are using, that also we'll discuss during our mix design process. Another thing is density of the concrete is also very important. Why important is, suppose you are doing around 1000 cubic meter raft and we are taking RMC, and we'll find that instead of 1000, at the end you consume 1000 200 concrete. Is 200 cubic meter extra concrete has come. That is possible. So one has to be very carefully whenever your design mix, your yield has to be checked. Means when I design for 1 cubic meter and I produce concrete 1 cubic meter, my volume should match. If it doesn't match, then we have a lot of issue, commercial impacts. Also, there's a issue in mix proportioning also. So that is very important, density of the concrete. Sometimes 1000 cubic meter, you end up with 990 cubic meter. So your yield is more, somewhere yield is low, which is not acceptable. Within 1% or maximum 1.5%, it is acceptable. But more than that, not possible, not advisable. So one has to carefully design concrete, and whenever you design concrete, one has to check the yield of that particular mix. How the yield is affecting, that we'll discuss. But it is also very important. So whenever RMC comes, we are also advising them in randomly, you don't only believe only on the batch sheets or the printouts which is coming as a challan, where they have put all the concrete quantities and everything is there, which is loaded into the transit mixer. What we have to do is you have to weigh the transit mixer. When it comes, we weigh it. Once it's empty out, also we weigh it and find out how much concrete has come. In concrete is what is happening is in batching plant, everything is whereby put by weights. Means so much kg per cubic meter, kg per cubic meter. But when they are selling to the market, they are selling in cubic meter, not by weight. If they are selling by weight, no issue, because every truck has to wait and then go. But I have got particular volume and I'll just pour into that. It has to match that quantity, whatever theoretically I calculated the volume. Even I am giving advantage of steel, which is there, which is not deducting by RMC, this owner. That is maybe around 2% or so. Even though that volume sometimes not matching. With a big project, if you are working, at the end of the project, you will find after 6 months or 1 year, you are end up with a very high concrete consumption. And you are paying only on cubic meter basis. Or if you are agreed only whatever your supply is there, or as per my theoretical volumes are there, I will pay accordingly. But that contract should be said at the initial stage. Otherwise, we'll have a lot of issues in the concrete. It is a very big commercial impact on the concrete. So one has to remember density is also very important. So when you design concrete, you take the theoretical density, add all the ingredients, say 2, 4, 5, 0, something like that. And after making concrete, you take the density and find out whether they are matching with 1.5%. If it's not matching, there is a drastically change, there's a change in your mixed designs. But all your mixed design based on absolute volumes. So volume has to check. We are taking about 1 cubic meter and then designing the concrete. So one has to be very careful about density of the concrete, which is very rarely we measure at site. So when you are witnessing any plant, any trial mixes or mixed design trials at the batching plant, you must ask them the what is the theoretical density and their witness about the actual density. The deviation should not be there 1 to 1.5%, not even 1% for laboratory level. Batching plant maybe 1.5% is okay. So that one has to be very careful. Now this is what happening, dispute about the quality of now the sampling, how much sampling has to be done. That has to be agreed upon at initial stages before proceeding for the concrete. If you refer IS 4926, they are given the frequency. That is for guidelines. But you can have your own frequency also. So otherwise, there is a variation may occur in the test result or an unnecessary dispute in quality of the concrete. Because challan comes, but we don't know what is there inside. We are just believing them. We have trust. So whenever you are checking the challan, one has to see when the concrete left from the batching plant. See the time when the concrete has batched. You see that time also, and we know the average time required to reach at site. So there is a practice always. Once it is received at the gate, you put the stamp that TM has received. So you know the what is the time. If there is a deviation, that drastic change in that, there is a possibility that the mixer may not from the same site. It may not come from other site also. They may divert a lot of TMs also, depending on the situation. So that one has to very carefully understand this. Otherwise, there are a lot of difficulties later on. Now this is the code has now introduced in 2018 methods for sampling, testing and analysis. 1199 was there. It is a just revised and they added a lot of other tests also in this particular code. Few tests were there earlier, but now they are added into this code. And I think as a civil engineer, you must have a copy of this code, including all the parts, part 1 to part 9. Very, very important to understand fresh properties, how to test the fresh properties of concrete, right from sampling, testing, and analysis. So part 1, sampling of fresh concrete, how to do the sampling, what equipment we have to use for sampling. Then consistency of fresh mix. Then, as I said, density of the fresh concrete. We are going to discuss all in detail. Then air content of fresh concrete. Making and curing test specimens. This is also very, very important. Then they introduced this new self-compacting concrete. Earlier we are following European codes. Now IS code has introduced this in 2018 for self, because future concrete, most of the concrete will be self-compacting concrete, since we are facing a lot of problem for getting good skilled labor, workforce. We are lacking in workforce. So self-compacting concrete is one of the good solution for it. That also we'll discuss. Then setting time of concrete, as I discussed earlier. Earlier it was IS code 8142 was there. Now they are introduced under fresh concrete IS 1199. Then water soluble, acid soluble corrosion mortar, which is responsible for your corrosion of the steel, and analysis of freshly mixed concrete. That's the method where you can find out what is the approximately cement content and binder content, aggregate ratio, can be find out on the fresh mix itself. So that is also one of the methods given for making good concrete. How to control, because huge amount of concrete we are producing on regular basis. So it is necessary to understand whether the batch to batch variations are there. If the variation is there, they are within the acceptable limit. One has to understand, and then we have to produce concrete accordingly. Now sampling of the fresh concrete, IS 1199 part 1. Now sampling, earlier they are not saying take the samples, but now they are saying you have to have a scoop, you have to container or tray to keep the concrete in the proper manner, take the samples properly. For temperature also we should have a thermometer which can be used for taking temperature. See, this is, you can see this is the scoop, because most of the concrete now what we are producing, we are working for high workable concrete. So it is not advisable to go for the mason's trowel. Better you go with the scoop like this and wheelbarrow to having a proper sample. Because if the sample is flowable, you get only aggregate on the top surface, your slurry will flow away. That's why scoop is desirable always. You see that it is available at the site. So whenever there is sampling, we should have a checklist. What are the things we should have during sampling process? And that has to be checked properly. Now we have temperature. We have got now digital one. We have got alcohol thermometer, or we have dial gauge thermometer. Now all the thermometers, whatever you are using as per your convenience, you should carry the calibration certificate, is very important. And this has to be also periodically calibrated. So we have one calibrated thermometer in laboratory, which is calibrated outside with the standard laboratory, and that you can use for using this or this, because these are very convenient to use in concrete, because it will not damage. This may damage, but it has to be calibrated properly. So when you are visiting any plant or any concrete to inspect the concrete, you must ask what is the calibration of that particular equipment we are going to use. A digital thermometer or dial top thermometer, or you can use alcohol thermometer, because this range is about 50 degrees centigrade. If you mercury thermometer, it may go up to 150 or 200 also. But for concrete, it is advisable to go for alcohol thermometer, mercury glass in or alcohol glass type, which is very sensitive. Even you can measure 0.5 degree also, but minimum requirement is your 1 degree. Here also digital, but whether this digital is working okay, one has to check the calibration with the standard one. It's very important. Don't believe on the site. So calibration certificate we have to check. You have to check their validity. You have to check their traceability also. What equipment they have used for calibrating this particular thermometer. That is also well important in this. I think time is over now, just 11 o'clock. You have any question on this? We can continue, because this lecture may go another 2 to 3 sessions. That's very important, and a lot of tests are there, and that has to be understood very, very carefully. Because when you are handling concrete, you must know what are to be tests to be done on fresh concrete. Definitely we'll discuss about hardened concrete also. But once you make a very good fresh concrete, definitely will give better concrete, hardened concrete. So any question is there? You can add this for 5 minutes, and then we can go for next lecture.
Sir, if you want, we can continue also, because today we don't have any lectures from college side, as it is a
No,
bank holiday.
but I have another
And
program.
sir,
I can work only for 10 minutes, another maximum. Then
uh,
I have to go out.
yes,
I have some meeting there. But we
okay, sir.
can definitely discuss some questions right now for 10, because I want you should ask some questions, because I don't want to only just listen. You should absorb. I should understand how much you are absorb this, because this is very important subject to understand, because people are engineers are not taking much interest in the vocabulary. वो तो supervisor देख लेगा, वो mason देख लेगा. That is the attitude. One has to understand. Once you understand this, you can make a very good concrete at site and control over ready mix concrete also. We cannot just get the concrete whatever supply by the RMC. You should have your own requirement and demand for the concrete as requirement for the structural requirement. Yeah,
Yes. Students, you can ask directly questions. Unmute yourself.
you can also maybe discuss whatever we have covered. Anything is also you want to discuss, that also we can discuss.
Dhaval has some questions. Dhaval, you can unmute yourself and ask to yourself directly.
Yes.
Hello.
Yeah.
Hello, sir. What will be the slum range of the different element like for CC road and column, beam, and slab? What should be the range of slum?
See, column is maybe 140 plus minus 20. That depend upon what height you are producing the concrete or placing the concrete. Sometimes we may require up to 160 also. And slab not more than 100, 80 to 100. And pile concrete maybe 150 plus. But one thing you have to remember today, since you are not using natural river sand in the concrete, we are using only crushed stone sand. Now it is also not in Mumbai, other part of the country also they are slowly changing over because of the environmental issue. Because natural sand you may not get sufficient quantity. So when you are using crushed stone sand, your water demand going up. Now once the water demand is going up, you tend to use high range water reducing agents. It's admixture basically what we have discussed earlier. In that case, it's very difficult to get the slump. You get always a flow. Now one has to specify the flow, not the slump, because slump is going slowly going out from the construction sites. We are getting only a flow today. Very rarely we get, suppose M20, 25 is there or 30 is there. Some small houses you can use slump concrete. Otherwise, most of the concrete is flowable concrete. Now, whatever you ask the question, IS 456 has given the type of structure and what is the slump requirement. They have already given. You can just refer to that, the table. But that may not be applicable right now in the current scenario, which is happening in the concrete with crushed stone sand. Yeah.